Your first class one?
Yeah.
One class is every class. I said I so want.
Okay.
It's like 3 minutes. So it starts for like 3 minutes. Back to like.
I've got all my calculus.
All right, so the review for Spiral 2, you'll notice that some of the stuff came from Spiral 1 because we're revisiting things. That's why it's called a spiral. And then also introduces the new stuff, which is mostly solving equations. Okay, so this, though, is review, integers, something we definitely need when we're doing algebra. So a quick little review of integers. If you see 5 minus 3, you are taking away cold. So we're at 5, but you're taking away cold. What happens when you take away cold?
You get warmer.
You get warmer. So it's like, it feels like you're doing this, right? But what's the answer? 8. Right? If you are taking away cold, minus 3, you're actually getting warmer. You're up at 8. Am I adding, subtracting, multiplying, or dividing in B?
Multiplying.
Multiplying. What happens when you multiply a negative times a negative?
Becomes positive.
Positive. Do I need to write the plus?
No.
No, you just know it's
It
that's
doesn't have a
12.
negative.
Okay? Here, even though there's brackets, you see I'm adding a negative. Let's try and do this in my head. Negative 12, really cold. You're adding minus 7. Does that mean you're cold, getting colder or warmer?
Colder.
You're adding cold, so you're getting colder. Where am I? Negative 19, and then minus 2 gets even colder. Where am I?
21.
Minus 21. Okay. 6 divided by negative 3.
Minus 2.
Minus 2. Or negative 2. How come I don't do the plus?
Because there's nothing.
Right? And also, why did I divide before I added?
Order of operation.
Order of operation, bed mass. Very nice. So I did that division first. And what is negative 2, which is kind of cold, but now you're adding 4. Where am I?
Positive 2.
Positive 2. Do I need the plus?
No.
No. When I multiplied a negative and a negative, it got me a positive. What about when I divide them? Still a positive. So here, this is positive what? 5. Do I need the plus?
No.
No, but it doesn't hurt to add. Okay. Bed mass tells me I gotta do what first?
The brackets.
Yep. Well, you could rainbow. That's an interesting thing. It will work, but rainbow's usually when there's an X there. Okay, here we can just do bed mass. With X's, we can't do bed mass, right? So let's do bed mass. Rainbow would work, though. I want you to know that. But let's just do bed mass. 4 plus 2 is 6. So I got to do brackets first. I'm not going to do anything else. I'm just going to do the brackets first. Then, negative 2, bracket 6. What operation is happening here?
Multiplication.
Multiplication. So what is negative 2 times 6? Negative 12. And then over here, I had division. Can I do that?
Yeah.
Yeah, division and multiplication are at the same step.
24 divided by 12.
What's negative 24 divided by 12? Is it positive or minus 2?
No.
Right, because it's a negative. So since it's just minus 2, I just write down minus 2. Okay? A negative divided by positive is negative. Now I'm at negative 12, which is kind of cold. Take away 2, I'm even colder. Where am I?
Minus 14.
Minus 14.
Okay.
Okay? So a good little review of exponents. You want to put check marks in there so you know that that's something. If you did that by yourself and you got it all right, you probably don't need to study this. If you want more practice, you can go to page 5. There's some more practice. But if you did okay with that last night and now you're seeing that it's right, you don't need to do any more. All right. Then we did proportions, right? Solving proportions. Remember, we did a bunch of that. This was, I feel like it was before March break. Yeah. Okay, so it's been a while, so we got to remember. Now, 1 to x equals 5 to 10. This is fine, but you might like to see it written as a fraction instead. So 1 over x equals 5 over 10. Sometimes the numbers are going to be friendly. If they're friendly, you don't need to do inverse operations. You can just do your friendly stuff. So for example, what'd you do from 1 to get 5? Times it by 5. So if I went backwards, what would I do? Divide by 5. What's the answer? X equals 2. Okay? That's one way you could have done it. Why did I write 4? Is that why Caitlin's staring at me weird? Good job, Caitlin.
Tiny little eraser.
5 by 5 makes a little bit more sense. Thank you. Okay? So if they're friendly numbers, great. Are these friendly? Maybe.
Kind of, yeah.
Yeah? So let's see if they're friendly. Look, we might as well do a friendly way. What do I do from 3 to get 18? What's 6?
Times 6.
Times 6, right? It's always got to be times or divide, right? Not adding. So times 6, so that means x equals 30. Now, I will do it the other way because I know some of you are probably comfortable with the inverse operation. So I'm just going to do it the other way because the other way will work all the time. The other way, though, I have the x on the bottom. What's the first thing I should do? Yeah, flip them. Flip both, right? And then, since it's being divided by 18, what's the inverse of divided by 18? Times. Right, so you go 18 times this. Check that on your calculator for me. 18 times 5 divided by 3. Did we get 30?
Yeah.
Good. So are you going to get more marks if you do it the blue way? No.
No.
Okay. If they're friendly numbers, feel free to use the friendly way to answer it. But remember that when they're not friendly numbers, this way is going to work all the time. All right, in C, I've got a 3-section ratio. So I can't make a fraction here now, but I can still use my friendly idea. So for example, you see how the middle ratio is 4? And then it gets changed to a 20? What did I do to 4 to get 20? Times it by 5. Good.
Oh, why do I freaking keep writing?
I thought Randy was telling me to stop. Times it by 5, which means this guy must be times 5. So if it was 2, what's t?
10.
Yeah, 10.
My lines are not in.
And the 10 here, it also must be times 5. Okay, equals 50. Okay.
I did some long math here.
Now, if you wanted to go to fractions, you just don't write down all 3. You write down different fractions. You write down the first ones and the second ones. There's one pair. You could do the seconds and the thirds, or you could do the first and the thirds. Okay, but we don't need to do that, I think, with these friendly numbers. All right, how about D? Are those friendly numbers? Not so much. What do I multiply by 5 to get 4? That's not a friendly number. So that's where I'm going to use the blue method because I know it's going to work all the time. Your unknown is on the bottom. What should I do first? Flip it. Okay, divided by 5. What is the inverse of dividing by 5? Times it by 5.
9 over 4 times 5 equals 11.
And now you can just go to your calculator, not have to worry about it.
11.25.
11.25?
Yep.
Apparently this means 11.25.
I write it in okay, whatever.
Do people agree? You've all done it on your calculators, right?
Unless I'm wrong.
11 or 9 times 5 divided by 4.
Yeah.
Is correct. Okay. Do we remember this? You guys were really good at this before March break. We did them up on the whiteboards. You were doing that, right? So it's been a while. We just got to practice. If you want some more practice, where would you find more practice?
Do they even
The
exist?
textbook. Although I don't have ones here. There are some more on these ones. Okay. Now, we got really used to doing the proportions by themselves. These word problems, all we have to do is make up the proportion. We got to make up these ratios. Okay. And one strategy to make up these ratios is to do what?
The letters.
The letters or the English, right?
That's right.
So this question says, Pam drove her car 99 kilometers and used 9 liters of fuel. What ratio does it look like I'm talking about? Kilometers to liters? That was one way. Someone might have said drive to fuel, right? Doesn't matter, whichever you're comfortable with. And the ratio that Pam gives me is 99 and 9. Where does the 99 go? The top? Again, the English tells me that. And the 9 goes in the bottom. Good. The second part says, how many kilometers can she drive with 12 liters of fuel? Does the 12 liters of fuel go on the top or the bottom?
The bottom.
What helps you know it went to the bottom?
It's liters.
The English. Okay?
Okay.
And the thing I don't know is I'm going to be X.
32.
Okay.
132.
You might say this is a friendly number. I don't know. I don't think it's super friendly, but it doesn't matter. Is the X in the proper spot?
Yeah.
So let's do inverse operation.
Times 12. Or 12 times, okay.
Yeah, times 12, 12 times, same thing. Let's go to our calculator. You might go 99 times 12 then that way, or 12 times 99. Doesn't matter.
100
Divided by 9 is
132
132 what?
kilometers.
Isn't there another way we can do this?
Yep.
She can drive 132 kilometers with my sentence.
Like, are you saying without the ratio, or
Yeah,
just
I
have a
did
different way to solve? What?
I did like.
Okay, yeah. That would be reducing this, and you would get 11 over 1. And then, yeah,
So like I did like 99
divided by 9 is 11. Yeah. The unit weight's not going to work on this guy, though, so just be careful. Technically, I don't have a sentence here, right? She can drive 132 kilometers. And your car, most of the new cars will tell you this right on their dashboard. They'll tell you how many kilometers you can go before you're empty.
Yep.
Right? It's doing this ratio all the time.
Some cars have half gas and half electric. And then the gas.
Okay, Micah can eat 21 hot dogs in 66 minutes. Yikes.
Hot dogs over minutes.
You don't even want to know.
That's why. Wait. Okay. That's how I put it.
Could you eat 21 hot dogs in 66? That's an hour. Could you eat 21 hot dogs in an hour?
100%.
Maybe.
Double it?
You could double it. You could easily that one.
It says you can double it.
Double it?
Well, at least you more than double it.
Joey Chestnut can do 67 of them in 3 minutes, in 5 minutes.
How about we stop avoiding test winning?
Oh, yeah, I know. I don't think so. I don't know. I think I might bail. Has anyone been to the Blue Jays when they do the Looney hot dogs? No, not on Looney hot dog ones. They do. Jays ones do have footlong ones, but on Looney hot dog days, they're only cost $1. Oh my God, it's bad. It's bad. Okay, let's focus. We've lost focus here. Hot dog over mins.
Yep.
So 21 goes on top.
I just did M, but
Yeah, that's fine.
I didn't do that.
It's English that you're going to understand.
I did
Okay.
HD over
how many minutes it would take to eat 35 hot dogs. So does 35 go on the top or the bottom? Again, what helped you with that? Yes.
Raging at this friggin' thing. I have my eraser and then I don't.
Are these friendly numbers?
I lost the count.
Not really.
Oh, flip it.
Unit rate would be harder here now, you agree? Be hard, you could do it, but it's not quite as handy. What will work? Inverse operations.
Good job, Trey.
I knew it was someone over here. Trey's gonna pass.
Yay.
Okay. But before I can do inverse operations, I gotta flip it, right?
Yep, sure.
66 over 21
Oh, yeah, I did
equals x over 35.
66 times 35.
That's right, times 35, then divided by 21.
There's 110.
110?
Yeah.
110 what? Hot dogs? Minutes?
Ooh, it's not that funny.
It would take 110 minutes. Now, you'll notice that I said, keeping up the same pace. Because if this was in reality, she might not be able to keep going and eating at that same pace. But assuming you can do that.
Now I'm hungry. I'm so hungry right now.
I don't know about like
I wouldn't eat
30 is a lot. 20 is a lot.
10's a lot.
If I'm doing this on
10.
10 is
I can do 10.
If it was like,
But
I
30.
can do like 5.
Okay.
I want like a
Do you have this one next on your sheet?
yeah, I do actually.
Okay.
Oh my gosh.
I'm going to guess that this one is slightly different. Amy drove her mother's house to her mother's house, which is 255 away. Why am I talking over? There we go. 255 kilometers away. It took her 3 hours. What was her average speed? What am I actually trying to find here?
How many kilometers do you do per hour?
Per hour, which is called a unit rate. There you go. All right. So the unit rate, you can actually see it in the word kilometers per hour. What does the per mean? That means
Me and my teammates
divide,
are trying to meet up.
right? It actually means divide. So we would go 255 divided by 3, 85 kilometers per hour. Okay, so unit rate.
Oh, I don't know. Actually, I did that. Major League Baseball is a long time. But, like,
What's next? Is the next one about?
did I get this right? I did. It is about Daniel and Sarah.
And Sarah. Says Daniel answers 240 questions correctly out of 300. Yikes.
I did not.
Can you imagine having to do 300 questions? This is a university exam. For sure. They do this all the time. My psych exam was 300 questions.
Is it like one of those where it goes like circles?
Yeah, you gotta do your dots. Yeah.
All multiple choice.
All multiple choice, 300 questions.
Oh,
Not fun.
I'm getting
Okay. Anyway, Daniel answers 240 questions out of 300. Sarah answers 328. Who performed better? What am I looking for here? A unit rate. That's right. Okay, so what? 240 out of 300? Should get a decimal maybe?
Yeah, 0.8.
0.8?
And then I
If we
timed-
wanted, this doesn't ask, but if I want that as a percent, what would the times by 100 be? 80, that's right.
I did that.
Sarah got 328 over 400.
0.82.
0. What?
82.
82.
Times 100 equals 82.
82. So who did better?
Sarah.
Sarah.
So satisfying.
Okay, so some nice unit rate stuff, just some simple proportion that we've done before. Clearly, this is a unit rate question. We're looking at laundry detergent. Exciting. It comes in 3 different sizes. We're not going to get fooled. We're not going to get the Costco effect here where we're just going to assume the biggest one is the cheapest. We're going to find out. Okay. And in the question, it even tells you what you need to do. What operations do I do here? How do I figure out the unit price?
Division.
What division? You're right.
Cost divided by size of.
Cost
load.
divided by load. That's right. So 549 divided by 10.
Equals 0.549.
Am I going to round that number?
No.
No. Remember you guys did an assignment with all these questions on it? A few people rounded. And if you round, sometimes you get the wrong answer, okay? So be careful there. We're going to try and keep as many decimals as we can. All right, what's the next one? 849?
849 divided by 20.
0.4245.
Yeah.
Okay. So far, the second one's winning. Let's try this 999 one. By 37. Exactly 27? Did it work out to exactly 27? Okay.
Yeah, it did.
So not really close, is it? Which one is best? Yeah. Lowest unit rate. Is that always the case? The bigger is always cheapest? No. Remember the bagels. How much would it cost you to do 100 loads with the Best Buy? So if this is 27 cents per load, isn't it? So if I'm doing 100 loads, what am I doing? Times it by 100, $27. Very
Oh,
nice.
I did not do that right.
Okay, good job. All right, so far so good. So that's kind of like, you guys were good at this, but it's been a while. So we got to just remember that. If you need some more practice, look on page 237, number 4. There's another one you could practice. All right. Also before, actually this was just after break, I think. We talked about direct and partial variations. Remember those? We did the Desmos activities. We were talking about like the socks and the Twix bars and the going to the fair and saving money and all that stuff. So this is just an example of that exact same question, but on paper instead of on Desmos. Let's read this scenario.
Oh, you have to draw.
Batavia Ski Hill offers lift passes for $12 per hour plus a rental fee of $28. So if you go there, rent some skis, and ski for 0 hours, how much is it going to cost you? Right. Of course, I don't think anyone would do that, but the idea is if you go for 0, you still got to pay the 28 just to get the rental, okay? Just like you had to pay just to get into the fair or for the large pizza. But if you go for 1 hour, how much do you add to that number? 12. So that becomes what, 40? And then 2 hours, you add another 12?
52.
52,
64.
64,
76.
76.
Yes.
I bet you can tell me the first difference without actually doing the math.
12.
It's 12.
So you get.
Did you know that from the question?
Fill the cup.
Yeah.
Like a package.
Look up in the question. Which one is the thing that changes and which one is the thing that stays the same? The 12 changes every hour, right? It's going to go bit, bit, bit. The 28 doesn't change based on the number of hours. So you know this is 12. If you want to confirm it, you see that these numbers are going by 12. I'm going to go right down to the equation now then. You know it's $12 per hour. First difference is 12. So the equation is y equals 12x plus
Oh, 12. That's how you write
the
it.
28.
I could not remember how to write it.
Okay? So we started off with ones that didn't have a flat rate, and we just said y equals 12x. Remember, we had the Twix and the racing car and the duplicates and the tricycles. It was like 3x, 2x, 24x. This one is 12x, but of course it has a flat rate, so we know we have to add the 28. I could quickly draw this. Plot these points. Starting at 28, that's 0. And then 1 is 40, 2 is 52.
Do we have to draw?
60. Yeah,
Okay.
that's why the chart's there. I think, do the instructions not say draw it?
Nope. No.
I guess, well.
Oh, and plot the points on the graph.
Oh, shoot.
You didn't read that part.
Yeah, right there, see? Last question. Is it linear?
Yeah.
Yeah. But should it be a straight line or a dashed line? Mine says straight line. What do you think? Do you agree with her?
I did not line those.
Why'd you say straight line? You can do half an hour, right? You do a quarter of an hour. Now, who knows if they would actually charge that way, right? But it is possible, so we're going to do the solid line. Okay? Yeah, they'll probably say if you go for 2.5 hours.
Night pass, so you have 4-hour intervals.
Right, yeah, they might give you something like that. Okay? Since it's a solid, is it discrete or continuous? Continuous. You can continue in between the points. That's why it's continuous. Okay.
Rewind.
You can continue between 1 hour and 2 hour. Oh, you're answering the next question, aren't you? Do you remember the reason we typed out linear?
First differences?
Yes. First difference is the same. So let's make sure we write these down. First difference the same. We didn't answer this one, positive or negative though.
Positive. As hours
Positive.
increase, so does cost.
Yeah, that's good. As hours
I just remember this.
increase, cost increases. There was only one that I think went down. Do you remember that one? She was like saving money and then she spent it. So as time increased, her money went down, her money decreased. We already decided it's continuous. Maya gave us a good reason because you can do like 1.5 hours. And then on one day we had direct ones and on the next day we did partial or indirect. What was the difference between the direct day and the indirect day? Right. And which one does ours have? Does it have a flat rate?
Yeah.
So it's indirect. Direct are the ones that start at 0. This one because you have a flat rate. Eventually we'll probably stop calling it a flat rate and we'll start calling it initial value, but they both mean the same thing here. Initial value is like what you would pay at the beginning of the initial time. So it's flat rate, same thing. What do you think I'm going to have you highlight in this next question?
Use the equation.
Right. Because this is a algebra practice. It is not a logic practice. I know that you know how to answer this without algebra. The point of this is to practice with algebra. So remind me of the equation. Y equals, thank you. And it says the cost is 8 hours. Is that your X or your Y?
Cost 4.
X, that's right. You can get reminded of that from your table. See, X is first, Y is second. Time, cost. So X is 8. That means I substitute the X for 8. So instead of 12 times X, it's now 12 times And look, this is the algebra, the logic you would have done anyways. You would have done 12 times 8 and then just added your thing. It's just written now using the algebra. Help me out here. 12 times 8 is 96 plus 28 is
124.
finish with. It costs $124. This is the exact type of question that you could have used for your worksheet, right? The one that you're going to create your own. This is the same scenario. Second one, I've got 100. Is that the X or the Y? Because I think it's really important. Which is it? Because I think we need to know.
It is the Y.
Oh, the letter Y. Oh.
Don't get old.
Oh, it's totally old and it's totally terrible. But guess what? I'm doing it again and again and again.
Okay.
Why? Because I'm a dad. Dad jokes. Dad jokes. Bad dad jokes. So use equation. This time, where's the 100 go?
In front.
In the front, in the Y. And what did we get? Everybody, what did we get? Our favorite equation. I don't think the recording got that. What did we get?
Our favorite equation.
Very good. All right. Which means we got to do what?
Man, it's such my
I got to
favorite.
minus the 28.
My favorite so much that I forget.
Here. Forgotten how to do your favorite equation?
Yeah, I forgot that it was my
We got to get rid of the
favorite.
flat rate. We got to get rid of the 28. We got to get rid of the cubes, right? Ignore the cubes we can see. How many's left over?
72.
72. So I've got 72 cubes. 72 cubes, but they're under 12 cups.
The X is on my side.
By both sides by?
The jugular.
So what is that, 6?
I know.
6 what?
Just to replace all the
6. 6 hours. You get 6 hours of skiing.
I'm not coming I think I'm
Okay. How we doing? Good. We've hinted at doing some algebra. Now we're going to do the real algebra. We have 3 different days of algebra. The first one was called one-step equations. Then the second day was called, and the third day was called, well, multi-step, yeah. Okay? All right.
3 plus steps.
Yeah.
So, what does this one look like?
5n plus 5. Our favorite.
What type of equation is it?
Our favorite equation.
Our favorite equation. Thanks, Annie, for nothing.
No, don't point me out.
I'm just pointing to the recording. They're going to know.
I'm gonna be yapping.
It's this. Yeah, I know. They're not going to be able to hear or anything because you guys are talking. Okay.
Gossip.
It is our favorite equation. This feels just like the cup math, right? 5 cups. I know there's 45 in total. I can only see 5 of them. What I got to do first?
Take away the 5.
Take away
Isolate the
5.
Do they cancel each other?
So that's gone. How much is hidden under the cups?
40.
40.
If you take away 5.
They're hidden, divided evenly into 5 cups. So divide both sides by
5. N equals
8.
n equals 8.
Oh, I forgot to put check marks on my other one. That's right. That's right. That's right.
Okay, there's a reason why that was the first one, because that's the one we all need to be able to do. We're going to be doing that one all year. Okay, next. IC divided by 4. What's the inverse of divide by 4?
Times by 4.
Times 4. It feels like we've already done this question, isn't it? Yeah, and that's by design. Okay? When we were learning algebra, or when we were learning proportions, we learned there that we had to multiply by the inverse operation, okay? And so it's -2 times 4, which is -8. Negative times a positive is negative.
I was right.
Okay. In C, it is our favorite equation. Thank you, Randy. Okay. Even though it's got negatives, our steps are still the same. So first I got to get rid of the number, right? I want to isolate the variable. I want to get it by itself. So this is a -5 though. What's the inverse operation there? +5.
-2n equals 40.
So that's going to immediately be with -2n. Good. Don't forget about that negative. Equals 40. Now I'm going to divide both sides by. Good. Caitlin is reminding me it's -2, right? Is that important that we forget the negative? Like we got to remember that negative as well. Divided by -2. Do you see subtraction here? Not really, right? This is a -2 times the n. So it's not, we're not going to, a few people sometimes put a plus here because they think they got to do the opposite sign. But you're doing the opposite operation. The opposite operation is to divide. So you got to keep that number the same. Okay, we divided by -2. Don't switch that sign. Did we switch the sign up here? It's just a 5, so we divide by 5. This is a -2, so we divide by -2. All right, so be careful here. This is a positive divided by a negative, so that is -20.
Look at my
All right, so far so good? Okay. All right. So I think A was two-step, C was two-step, B was one-step. This one is like 3 or 4, or maybe more. It's multi-step. Okay. So this, by the way, you're setting up for grade 10. This one, you're going to be doing tons of these in grade 10. That's why we're making sure we're good at this. There's a real application for it in grade 10. All right. But right now, we know that in our strategies, we got to put all the letters on one side. So think back to the hanger that I drew on the board there. Remember, we had X's and X's, and we moved X's, right? Or we canceled X's, and we did that. So we were allowed to move or do inverse operations on letters as well. So you could move either, and you guys did this on the whiteboard beautifully. So let's do the same thing. I see a 4X. That's the one I'm going to move. I like to put my letters on the left-hand side. So an inverse operation, what am I actually doing?
Subtracting.
-4q minus 4q. It feels like I'm moving it. And that's why people say I moved it from one side of the equal sign to the other. But remember, it's like I'm taking away x's from both sides, right? When I think of the hangers, I took away the, well, q's in this case. By taking them away, how many q's do I have left? 4q plus 6 equals? Ooh, good job. Don't forget the minus. Good job. And then guess what we have?
Gotta get rid of this darn
Our
6.
favorite equation.
Yes. And we got to do what?
Get rid of this darn 6.
This darn 6. What did the 6 do to you?
I don't like
Everything.
You just got to say, hey,
It has
6,
to be gone.
thanks, but I'm going to ignore you.
Why are we thinking it?
Well, because it's nice. I don't know where we'd be without a 6. Okay.
Be far in life.
Where?
Lawyer.
All right. Now, be careful here. I'm actually taking away 6 from both sides. Am I warm or cold with -14? Cold. And then I'm taking away 6. Am I getting warmer or colder?
Colder.
Even colder. Where am I?
-20.
-21. thought 20.
Why
Someone
20?
said 21.
Who said 21?
I don't know. I think it might have been me.
All right.
So you're getting colder, right?
I somehow wrote it.
Oh, okay, that's fine, but can we see how this? Yeah. Okay. Divide both sides by 4. So what is Q equal to? Q equals, why is it -5?
Because you were dividing our negative by a positive.
Good.
Negative. 2 more.
Okay, how are we doing? Are we done yet?
2 more.
We got 2 more, right? Guys, our last steps are definitely multi-step, okay? And the multi-step means we're going to use some algebra to simplify, right? Let's make our life easier by using the tools of algebra to simplify. You can see why we spiral our curriculum, right? Remember, we've already done collecting like terms and rainbow and distributive law. We made sure we were good at it so that we could now use it a month later in these questions. All right. I can tell that I have to rainbow. Remember back at the beginning, the very first page, we had something in brackets and we added them together, right? We did bedmass.
Yeah.
Can I do bedmass here? How come? Unlike terms.
Rainbow.
Let's try that again. Can I do stuff in the brackets here?
No.
How come?
Unlike
Very
terms.
nice. Which is why we needed to know rainbow. We needed to know the distributive property. So you're going to rainbow. Now, what am I rainbowing? 3? -3. And rainbow is what operation?
Multiplication.
Multiplication. Okay, so it's times. So now, help me out here. What is -3 times 7p? -21p. Good. And then be careful here. A negative times a positive 5 is a negative.
15.
Right, so I just write down -15, right? The negatives will take care of itself. I don't want to see plus minus. That feels weird, right? Okay, so it's just a negative times a 5 is a -15. Does the -3 get rainbowed by the 27? No, it's on the other side of the hanger. It's someplace else. It's totally different. Not inside the brackets. Where's that? And using the distributive property and rainbow, I now have our... Man, one of these days. Okay, yeah, well, so we're a little late to the party here, but, you know, whatever. Okay. All right. What do I got to get rid of first?
15.
Okay, except it's not a -15, so I got an inverse operation is
Plus. Addition.
okay. You can see why I've been such a pain with form, right? Trying to get you to do form because it's very easy to get lost with all your other methods. But here you can clearly see the inverse operation is to plus. All right, so by doing the inverse operation, you are ignoring the 15s. Doing the inverse operation. On the right-hand side, what do I left with? 27 plus 15.
42.
42, that's right, yeah. I've added 15 to both sides. It's like I was missing them on this side of the hanger, so I got to balance it by doing 15 on both sides. What am I left with over here? Very nice. Nobody forgot the negative, which is good. It's very tempting to forget the negative. All right, so I've done putting my adding and subtracting. Now I got to do another inverse operation. Divide both sides by
-21.
-21. Good.
Negative 21.
Don't change the sign. We are dividing.
P equals -2.
Is it -2 or just plain old 2?
-2.
Is it important that it's -2?
Yes.
Yes. All right.
Hi, John.
Okay, positive divide by negative. Last one. We're doing well. We're doing really well. Okay. This is the one. If you can do this one, you can probably do of all the other questions before, right? So, simplify first. What am I rainbow in the first one?
3 times x. 3 times -4.
This one's quite silly.
This one's quite silly.
What am I rainbowing the second one?
2 times -2x. Yeah.
Oh, there you have 4 plus
It's
2.
-4x.
How come it's not -2?
Because it's a positive times a positive.
Right. How come this one's a minus though?
It's a positive times a negative.
All right. You have some decisions to make here. We want all the letters on one side, numbers on the other side, just like we did over here. Oh no, we didn't do it here. So before I deal with the 12, you're right. We know we got to do the 12, but I first need to get all the letters on the same side.
Oh, wait, that's later.
You're right. Well, thanks. Okay. So,
That's very true.
all right. -4x.
Plus 4.
Right. Let's move that one to make it +4x.
So we don't get to -7.
Why did I write the +4 underneath this guy?
They're like.
Because like you.
Sorry.
Because we have to do that.
Okay, fair. Why do we have to do that? Why am I putting it under the 3x?
Because they're like terms.
They're x's. You can only add x's. Can I deal the x in the 12?
No.
No.
On my turn.
Yes. Good job. All right. So how many x's do I have now? 7x
7x times 12 equals 2.
minus 12 equals 2.
Plus 4.
Okay, this is the last chance recording to see if my class can actually do this.
Oh.
What type of equation do I have?
Our favorite equation.
Inverse operations. Do what?
Plus 12.
Plus 12.
Plus 12.
Plus 12.
7x equals 14. Divide both sides by positive 7 equals x equals 2. Another check mark.
Okay, so I added 12 to both sides, got me 14, divide both sides by 7, and we're set.
5 minutes.